Hello everybody, welcome back to 2020. It's already 2020 now. As I'm finishing up with one project, I'm looking at another one. This one's going to be more of a detective case. I don't know how far we're going to go with the restoration of this. A subscriber reached out to me back, in the summer now, and said, would you mind me giving your email address out to another friend, and I believe he's a subscriber also. And so he contacted me. He was having trouble with this particular radio, and I'll give you the symptoms. He was bringing it up, and he had got it to 30 volts, and it was pulling 500 milliamps, so he backed off. And so he had replaced some caps. He tested the tubes. Everything was good. He replaced the caps several times, thinking it was something to do with that. He did the right thing backing off. So anyway, long story short, the background of this particular radio is he had went to buy a radio, and now this is my understanding, I hope I get it correct. He went to get a radio and picked it out, and the lady basically gave him this one, and he initially started working on this, and he realized, I think, that this wasn't the primary radio that he was after. So he did some more troubleshooting, and he indicated to me that the transformer, one of the windings was open. So he boxed it up and sent it to me. Wouldn't take any money for it. So what we're gonna do is we're gonna do a little detective work, and we're gonna go through here, and we're gonna see exactly what it is. He didn't want to put that much more time, effort in for it being a transformer, but I think there may be a little bit of a surprise. I don't know. We'll see. We'll see how far. If we get to a certain point that we see that this is going to be something that we can restore, I'm going to offer to give it back to Terry. It was Terry. I won't mention his last name, but Terry sent this to me. So Terry, if you're listening out there, if we find something that if it looks like it's going to be restorable, I'm going to send it back to you. So you might as well get ready, unless you come and force me not to. So, all right, let's take a look. He had written some stuff down, sent me some of his drawings. Had taken the transformer out and some of the miscellaneous parts. Now, here's the other part of the. Now, I don't think Terry gave me that. I mean, he gave me this envelope, but I don't think this is Terry's envelope. If you'll look at it, I don't think. But what it is the spare parts and the little tacks. Now, that's going to come in handy because those tacks are hard to come by, and a few washers and things like that. So we're going to save all this and everything. So first thing I want to do, since he thought that this transformer was open, then we're going to try to identify these leads on here. And what I'm suspecting right now is that whoever worked on this radio before Terry had the rectifier wired wrong. And I'll give you a little bit more clue how I think that later on. And I may be totally wrong, but that's my first initial assessment. So let's see. Now, I've tested this transformer, and I'm going to recheck it again right here on camera, and so that we'll all be on the same page. Okay, when Terry pulled this out, he labeled the wires. It's really hard to tell the colors of these, but we'll see what we can do with them. So this one over here is labeled pin 1 and 6 on the 42 tube. So that is going to be the 6.3 filament, if that's correct. And if that should be somewhere on the order of less than 1 ohm. And I think everybody will agree with that. And let's look at that. Right around 0.9, 0.8 till it settles out. So it's less than 1 ohm, which that's what we would expect. Now this says primary hot to the switch, and this one is the primary neutral to the bakelite block. And that would be these two wires, 1 and 2, in the schematic. And we would think that on the order, since we just come out of that number 80, we would would think that it would be on the order of 10 ohms, 12 ohms, 15 ohms, somewhere along in there. So let's check that out and see what it says. There's right at, let's see, make sure you get it. Hope that's not glaring. And it's not. Right at, just at 10 ohms. Okay. Now, here's where the problem could have very well come in. We have got pin, there's your center tap. That's the center tap. Okay, that's center tap, the high voltage. Then you have pin 1 of the 80 and pin 4 of the 80. Okay, so pin 1 and 4 is going to be the filament, which should be 5 volts, which should be less than 1 ohm. So let's check those out real quick. There's pin 1, and there is pin 4. And we are looking at 417 ohms. That sounds more like the high voltage windings. So to prove that, or to check that, let's take one of these leads and go to the center tap, and it should be approximately half of the 400. And there's 201. Let's go to from the center tap to the other one, which is pin 4, and there's 216. So, according to the way this is labeled, pin 1 and 4 should be the filament and a low resistance. Okay? So let's go to pin 2 and 3 and check those, which in theory should be the high voltage windings. And I think this is where Terry's troubleshooting thought he had an open lead. Let's make sure I get a good one. So from 2 to 3 is less than 1 ohm. So if you go to the center tap from one of those, it's going to show that it's open, and so the other one. So what I'm thinking is that someone prior to Terry had wired this transformer wrong in the radio. And when he labeled it and started doing the troubleshooting, it showed an open from the center tap to one of the leads 2 and 3, which in fact should be 1 and 4, and the 1 and 4 should be 2 and 3. So let's put some power on it and check some voltages. Okay, I've took a power cord and I've wired it to the primary, and I just slipped some heat shrink tubing over the end of it to keep them separated. Also did the rest of it except for the high voltage. Now I've got the 2, the 3, I got the center tap, and if you'll remember, the ones that are marked 1 and 4, we believe that it's opposite. So these are actually pins 2 and 3 on the rectifier tube. So I've got the voltage on my variac, I've got it down to 12 volts, which is 1/10. So we want to see that we don't have a major problem to start with. So we're starting out 1/10. This is a center tap transformer, so the transformer is, what is it, 350-ish each side, so it's about 700 volts. So we should be looking at close to 70 volts AC on the high voltage. So let's flip it on. I'll look at the current while we're doing it. No current at all to speak of. And we're looking at 67 volts. So let's go to the center tap. That is still knock a soup out of you, so you just need to be careful. So half of 67 is going to be 33, 34-ish, somewhere along in there. There's 33.5. Okay. So since we got that on the center tap, let's go on to the other side. And there's 33.4. So the high voltage looks okay. Since I'm just going to go ahead and run it up. I'm going to go off camera, run it up here. So let's see. We've got the high voltage, so let's go all the way up. See what we're going to have. Now this is unloaded, so it's going to be probably in excess of 700. Very little current at all. There's about 110 volts on the primary, and there's 120 volts. And that's half of it. That's I messed up. That's half of it. That's 330. So let's see what the full is. There's 663 volts. Very little current at all. So let me run this back down to 12 volts, and then we will look at the other voltages. I've covered the high voltage leads with some heat shrink, and now I'm on the 6.2 or 6.3 volt windings. I went ahead and left it, since I've got the high voltage covered up, I'm going to go ahead and leave this as 120 volts. So we should see something above 6.3. It's unloaded, so it's going to be probably closer up to 7, maybe. High 6s. Let's see what we got. 6.9. That sounds right. Okay, let me go to the next ones. Okay, I've covered those up. Now I've got these on the ones that are marked pins 2 and 3, which in actuality we believe it to be pin 1 and 4 on the rectifier tube, and that would be the filament on the rectifier tube, which is 5 volts. So it's somewhere between 5 and 6 volts, we believe. I've still got this on 120 on the input, and there's 5.5 volts. So the voltages look right. Like I said, I believe whoever worked on this prior to Terry had had worked on the transformer. As you can see, it's been taken apart before. So I'm going to take the clamshells off and look inside and see if any work had been done. And then if whatever we find in there, I'm going to put it back in the radio, and we're going to start bringing it up or fixing it from there. Yeah, I've got an email into Terry and see if he had gone inside this to look for loose wires or not. The tabs have been bent up, which tells me he probably did this because this would not bolt back to the chassis with those tabs up. So he probably did this to look and see. Here's a piece of tape, and I think that was to hold this on. I believe. I don't know why the tape would be on there unless it was to hold the bottom plate on. Well, or to occupy a monkey. That may be what that's on there for. Because it sure is occupying this one. Yeah. So, yeah, that's what that was for, is to hold that on until we, here's the part number. 7180. Does that sound right? 7180. I believe that's right. Let me, quick reference here. I got parts list here. 327180. Okay, so that is that. So let's pull this up and pull the clamshells off maybe. As you can see, it doesn't look like anyone has tampered with it. I think he made mention that he might go inside this and look, and he might have got this far and said, you know, I ain't messing with it. I don't want to guess exactly what he done, but it's untouched and the wires look okay. I'm not going any further in. I'll do a final check on this to gotta make sure these are put back on correctly. Now what I plan on doing is I'm going to get me a piece of wood and bend these down, these tabs. Make sure they're down. Let me bend those down, then I'll do a continuity check, make sure we didn't do any damage, and then we'll mount this back in the radio and start wiring it back up. I took that piece of wood and bent those down. This right here, I don't think it got hot. That could be rat urine right there. I don't know. I thought at first it might have been had gotten a little hot, but it's some sort of corrosion underneath there, so it might have been urine run up under there. But I did do a continuity check, and it does test back out the same. I pulled the chassis out of the cabinet. Fortunately, I still had the cardboard from the 84B, the basket case that I had done, and so I just put it on the speaker to protect it. And then I went back and looked at the video and saw how the transformer bolted back in, where the wire orientation. Trying to figure out the wiring, what have you. Here's the power cord. We may not use that at this point in time, but we will do something. We'll figure out, we've got all these from the transformer to sort out and solder back in. These two wires, they go to the speaker. I've done sorted those out. This is to the B+. He had sent me some notes earlier. He had put a terminal strip in here somewhere to put the filter caps in, and I think he took it out. It's obvious it's gone, and so that's the B+. It goes over to this junction tab on this capacitor. This is the C24. Does that sound right? Yeah. But that's just a tab. That's just a junction. That's a terminal strip there. So, and of course this goes to the 16K resistor. I happen to have a spare one here to use. And that'll also go to the B+ So I think I've got enough information to go ahead and tack this in. I may put a terminal strip in also. I got to figure out where this one goes. But shouldn't be that big a deal. I'll figure it out. It goes to, let's see, that goes to C24, which is up probably the plate, which is probably, well, I'll figure it out off camera. But let me go ahead and start tacking at least the transformer back in and decide what I'm going to do with the terminal strip. I put a terminal strip in here, attached it to the screw, same as I used for the fuse in the Model 80, and then I just soldered to the chassis here. And I've got a 4.7 microfarad and a 10 microfarad. With this is the common, so this is where our center tap will go. And this is, I traced this lead in the last video. I didn't know where it went, so it actually goes to the common, the center tap there. So let me wire the rest of this stuff back in. I've got everything wired back. Went ahead and put some heat shrink on the filament leads. They were cracking when I was working with them. Tacked in a temporary cord. Put my 16K resistor in and double checked this wiring and wired up the filament to the rest of the tubes. So I think we're ready to try this. Okay, I've got the voltmeter connected to the plate of the output tube, and so we're going to be looking at somewhere around 240 volts, hopefully. If you'll remember, the initial problem that Terry had was when he was bringing it up, he would get 500 milliamps at 30 volts. So we're hoping that that's not going to take place now. The Variac is fused. I did not put a fuse in this circuit at this point, so let's turn it on and start ramping it up. Hopefully you can see the meter. This is the amp meter, voltmeter, and this is the DC voltage on the plate. So let's see, let's bring it up to about 30-40 volts. Well, I guess it would help to plug it up, wouldn't it? Turn it back down, plug it back up. There we go. Makes a good lesson learned there. Okay, let's bring it up to about 25 volts. Looks about like 100 milliamps. Little of illumination on the dial lamp. It's going up to 50. Start getting some movement in the DC voltage on the plate. Still 50 volts, less than 200 milliamps. So I think we're in better shape. So we're going up to 75, 80 volts or so. All right, we're getting, there's 240 volts on the plate, a little over 200 milliamps. All right, let's go up to 100 volts. Starting to get a buzz. Not me, but the radio. There's 400 milliamps. Let's go on up. Everything's looking pretty good. I'm hearing. All right, there is 120 volts. We're setting at 235 volts DC on the plate of the output tube. That sounds about right, and that's 500 milliamps. That's roughly what the 80 did. All right, let's hearing some noise. No station. Let's on the first detector, nothing. Yeah, I have an antenna hooked up. Nothing there. Let's go in here to the second. Oh. All right. Tells me it's in the first detector. We didn't check our coils or anything like that, but we do have good current flow now, good voltage. We'll check the voltages on the other tubes, but we're not getting anything here. So it tells me from this tube on, between this tube and this tube, we have a problem. And more than likely, it's going to be one of those notorious coils. So let's depower this and do a few checks and see if we can isolate it real quick. As usual, this video is running much longer than I had anticipated. So we're going to go ahead and end this one here now, and then pick up troubleshooting the coils and go from there. So, from Larry, from the hills of Tennessee, thanks for watching.